PyQt Advanced Handling Events. Hello everybody, this is Ben Finkel, and in this nugget we're going to talk about signals and slots, or how to handle events inside of the PyQt library. GUI applications are great, but if we don't know how to handle the different events that come up, they're not going to be any good for us. So we need to be able to tell our program what possible events are out there that we want to deal with and what it should do when those events come up. By their very nature, GUI applications are event-driven applications. What do we mean? Well, they sit there and run quietly, doing nothing on your system, waiting for some kind of trigger, some kind of event to come in and tell them what to do next. Right? This is what happens when you call the .exec on your application object in PyQt. You are telling the program to enter an endless loop and wait for some kind of event to trigger the next action. Those events can come in a lot of different ways. Primarily, you expect them to come from your users, hence user interface, right? So the user may click a button, they might type into a text box. Whatever it is they do, the user is going to do something that is going to send a signal down to your program to say, hey, this event happened. This button was clicked. You can also get events from a couple other places, though, and you don't want to ignore those. Events can come in from the system, right? So you might have the system sitting there waiting for a file to download, and when that file finishes downloading, it might trigger an event inside of your application. You might also have something that's going to happen at the stroke of midnight. So the system is watching the clock. When it hits midnight, it's going to trigger an event. A third place you can get events from is from you, the programmer yourself, right inside of your code. You might have something like a timer, and every 10 minutes, it's going to trigger an event to say, hey, we hit that 10-minute timer window. Now, if you've never worked with events and event handling programming before, it can be a bit much to get your head around at first. It's not so hard, but it is a unique way of looking at a program. Instead of just writing a big long list of code that's going to execute, you need to write these little pieces of modular code that may or may not execute. You don't know what order they're going to execute in. Also, if you are familiar with event-driven programming, it can take a little bit to get your head around the language in the unique way that PyQt handles events. So pay attention to the next few minutes. We're just going to go over it very briefly. What it basically boils down to in PyQt is this idea of signals. And signals are the events themselves. They are the click, the mouse move, the mouse release, whatever the actual specific individual event is called a signal, and they are attached to different objects. What you're going to use is the signal.connect event in order to connect a function, or a slot as they call them, up to that event, up to that signal. So what's going to happen is you as the programmer have to call button.clicked.connect, and you have to pass in the function, or you have to pass in the slot, they call it in PyQt, that you want to handle that event. So in more generic terms, or more common traditional terms, this is called the event emit down here, and this is the handler hookup right here. And you may be more familiar or comfortable with those terms. They might make a little more sense to you. But the basic idea is that you need to connect up these slots to these signals as the developer, and then the PyQt will handle the rest. As with most things in programming, it's easier to see in action than it is to explain. So let's take a look at some sample code now. Here's a simple GUI PyQt application, and I've got two elements, two widgets inside of my form, a label and a button. And notice I'm calling button.clicked.connect, and I'm passing in self.handleClicked, which is just this function that I define right on the QWidget class a little bit lower. It's going to handle the click event, or the click signal. So here's how I'm doing that. Button.clicked is the signal that I want to handle. .connect is adding the event handler, and the specific handler is handleClicked. So down here, when I do that, all I do is I change the text of my label to indicate that the button was clicked. And that's all I have to do to handle a basic event. I simply call the signal.connect, give it a function to execute when that signal is emitted, and when I call this code, python.events1.py, you can see here's my form with my label. It initially says hello, and there's a button that says click me, and when I click me, the text of my label changes to button clicked. Now, the first thing that you're probably thinking is, okay, that's great for button clicked, but what are all of the different signals that I can connect a function to? How many different events can I handle? And this is where the PyQt documentation is once again going to help. Open up my widgets and layouts documentation, and I'm going to go right ahead to the Q push button widget. That's the one we just worked with. And when you're looking at the widget documentation, as you scroll down, you'll see a section here for additional inherited members. And notice that the very first thing that's listed is signals that it inherits from its base classes. So it gets 4 signals from QAbstractButton, 1 from QWidget, 1 from QObject. A lot of the signals are implemented at a higher level than the base widget, so you won't see the signals defined down here at the widget. You have to come down and look and see where they're inherited from. So if I click 4 signals inherited from QAbstractButton, it takes me right to the signals on the QAbstractButton class, and I can see that there are 4 different signals that I can connect to: clicked, pressed, released, and toggled, which is going to work for the Q toggle button but not the Q push button. And if I follow the links on any of these signals, let's take a look at clicked. I can read a short description about how this signal in particular is emitted. And here we see the signal is emitted when the button is activated, i.e. pressed down and then released while the mouse cursor is inside the button. That makes sense, right? This event, this signal is fairly self-descriptive. That's what a button click is. But the devil is in the details. Notice that it's pressed down and then released is what triggers the clicked event. So until my mouse comes up, until my finger comes up off that mouse button, this particular event is not going to get triggered. And as I look back here, I can see that there's also a pressed and released. So I would expect a button click event to actually trigger 3 different events. Let's take a look at that. So here I've expanded my previous program a little bit. I've now got 3 different labels, one for pressed, released, and clicked. And you can see that I handle each signal separately with a separate handler down here on my push button. Handle clicked, handle pressed, handle released. And if I scroll down here, you can see the 3 event handlers that I've implemented. They each update a different label. So when I click it, I update the clicked label. When I press it, I update the press label. And when I release it, I update the released label. So the point here is to demonstrate that these events, multiple events, fire from what might seem like to us as a signal event. Run my form here. You can see 1, 2, 3. There's my 3 labels. Now when I click me, I'm going to hold down the mouse button for a few seconds here. So the first thing that happens is you see immediately pressed fires. My pressed event fired. My label was updated. When I release my finger off the mouse, I get a released event, and then very quickly, I don't know if you could see that, the clicked event fired as well. So these events, these 3 different events, fired from my mouse click, which felt like one event, 1, 2, 3. It's important to remember that frequently events are broken up into sub-events, and you need to decide exactly which particular event it is that you want to handle inside of your code. Now also recall that in the parlance of Python, these event handlers are called slots, and if you noticed in the documentation, you might have seen an interesting little thing on some of the different widgets. Let's take a look at QLCD number. This is a favorite widget of mine. Simply displays an LCD number. And when I scroll down here in the documentation, I can see that there is actually something called public slots. And these are things like set mode, set display, etc. These are slots, these are pre-written event handlers that I can pass into a signal. For instance, let's update an LCD number with a slider. Check this out. Here I've simplified my code dramatically. You can see all I've got is a little QLCD number and a QSlider object, and I connect to the value changed event signal on my slider, and I pass it in a handle to the slot from the LCD object that I just saw inside of my documentation, in this case .display. So I happen to know from looking at the value change documentation that value change is going to pass an integer in. So when I run this code, you can see I get a little slider and a little display form above it. And when I move the slider, it's tough to see, it's a little bit faded, but the number is changing automatically with my slider. My slider defaulted to 0 by 99, and that number is getting displayed right inside of my LCD window here. And it's cool, right? I did this by not implementing any custom code or any custom handlers. I simply took advantage of the available predefined public signals and public slots that these 2 widgets had on them. So again, a lot of work that you may want to do has already been done for you inside of the Qt library. Make sure you pay close attention to and review that documentation so that you can see the different things that are available that you can take advantage of without having to reinvent the wheel every time. That concludes this nugget on how to handle events inside of the PyQt library. We took a real brief look at how you can wire up event handlers or slots into event emitters or signals that the different widgets can produce. Importantly, we took a real good look at the documentation that's available so that we can explore and find out what signals and events are available to us and what event handlers are already available to us as well. I hope this has been informative for you, and I'd like to thank you for viewing.